Today, we are going to cover section 10.1b, verifying trigonometric identities. Go and take the time to copy your title and your essential question. How do you verify a trigonometric identity? Go and copy example number 1, and we'll start once you are ready. Go and pause it. So if you notice, we divide up section 10.1 into two parts. Just because once we get used to some of the strategies that we can use to simplify expressions with trigonometric functions, we can move on to verifying identities, which can be an easier process because you'll know where you need to get to. To verify an identity, we need to be able to simplify or substitute the left-hand side to make it equal to the right-hand side. Or we can simplify the right-hand side or substitute expressions that are equivalent so we can make it equal to the left-hand side. Or we can simplify the left and the right and meet somewhere in the middle. But both sides needs to be the same. Now we're going to use some of the identities that we covered on the last section. So you can go back to your notes. You can take a picture so you can refer back if you don't have an extra copy. Now, verifying identities. You need to decide what side you need to start, the left or the right. I'm going to start with the left. Now, one of the things that you need to be able to recognize is that whenever you have an identity that's being squared and a 1, that should drive you to your Pythagorean identities. Your Pythagorean identities have sine, cosine, cotangent, cosecant, tangent, and secant. Now notice that in here we have secant squared and a 1. So therefore we're going to use this one here. If we move the 1 to the right, it becomes a negative. So therefore secant square of theta will be equal to tangent. So I'm going to replace with tangent square of theta. That is the same as secant square of theta minus 1 according to our identity. Over secant square of theta equals. We can bring this down, or we can just go into the very end. Now, one of the strategies that we learned last time is that we need to switch everything to sine and cosine so we can simplify. Tangent square of theta, well, we know that tangent is sine over cosine, so therefore tangent square of theta will be equals to sine square of theta over cosine square of theta over secant square of theta. Well, I know that secant is equal to 1 over cosine, so therefore secant square of theta will be 1 over cosine square of theta. My cosine goes here. And now I have a division that I need to convert into a division to a multiplication by taking the reciprocal of your second fraction. So I want to change my division to a multiplication. My first fraction will stay exactly the same. So we're going to simplify this complex fraction. And I'm going to take the reciprocal of this fraction. So therefore, my cosine square cancels out. And the only thing that I have is sine square of theta over 1, or just sine square of theta. And therefore, I ended up with exactly the same on the left as on the right. And therefore, we identify our identity. We confirm that they're equal to each other. Now, there's going to be times that you can skip this step here by thinking about this complex fraction in a different way. I know that both of them have a cosine square of theta on the denominator, so therefore I'm going to extend each of the fractions, and I'm going to multiply this fraction. I'll multiply the top and the bottom by the same, which will be cosine square of theta. So I'll multiply by cosine square of theta and the cosine square of theta. Therefore, that cancels. This cancels as well. And the only thing that we have left is sine square of theta divided by 1, which is sine. So it's another way to be able to simplify that might be a little more concise. But one of the things that you have to be careful is that you want to make sure that you multiply on the numerator by extending this fraction bar all the way through. Letter B. I need to be able to simplify the following expression. Well, I need to verify the following identity by simplifying each of the expressions. So you have a choice. Do you want to start with the left or with the right? Well, on the right, we just have a 1, and we notice that we have a whole bunch of 1s that we can work with. So therefore, I'm going to start with the left. On the numerator, do you notice anything that we can replace? Correct. We know that sine square of theta plus cosine square of theta is equal to 1. So I'll replace it with the 1. My denominator will stay exactly the same. Now, the other strategy that we learned yesterday was to switch everything to sine and cosine to see if we can simplify it. Well, this is already cosine, so I'll leave that one the same. But I can replace secant square of theta with 1 over cosine square of theta. Be careful. Notice I'm going to place my fraction. This cosine stays in the numerator of the denominator of the fractions on the denominator. So therefore, my cosine square of theta are going to cancel. Very important is that you keep your numerator with your numerator, denominator with your denominator. So therefore, 1 divided by 1 will give us 1, and that is equal to 1. And you can rewrite the 1 all the way through, or you can just place an arrow. And we confirm that those two expressions are equal. So therefore, we verify the identity. So that's all we're doing today. We are just going to verify some of the identities, and we're going to use some of the concepts that we learned on 10.1a. Example number 2. Go and pause it if you need more time to write it down. So now we have an addition, and we want to confirm that these two expressions are equal to each other. We need to be able to verify the identity. So we know that if we have two fractions, we should add them. And what do you notice about your denominator? 1 minus sine of alpha, 1 plus sine of alpha. What is that called? Yeah, that's the difference of two squares, right? So therefore, we are going to add the fraction. So I'm going to start with the left-hand side. You can start with the right-hand side as well and try to see what you can simplify. But I know that I can simplify the left-hand side by adding both fractions. I'll multiply the left by 1 plus the sine of alpha. 1 plus the sine of alpha. And I'll multiply the right by 1 minus sine of alpha. 1 minus sine of alpha. And 1 minus sine of alpha. On the left, we're going to continue having 2 secant square of alpha. Notice that my denominators will be the same. Now, if I multiply my denominators, what will that give me? Correct. 1 plus sine square of 1 plus sine of alpha and 1 minus sine of alpha will be 1 minus sine square of alpha. Plus, the denominator will be the same. 1 minus sine square of alpha. 1 times 1 is 1. 1 times sine of alpha will be sine of alpha. 1 times 1 is 1. 1 minus sine of alpha will be negative sine of alpha. And now that we have the same denominators, now we can add the fractions, and it will give me, the denominator will stay the same. And now we can add the numerators. 1 plus 1 will be 2. Sine of alpha and sine of alpha, they will cancel each other, gives you 0. Now, keep in mind, what do I need to simplify? So every single time, you want to go back and say, okay, what do I need to get to? I need to get to 2 secant square of alpha. If you notice on your denominator, I can replace 1 minus sine of square of alpha with, correct. If I look at my Pythagorean identities, if I move my sign to the right, it becomes a negative. So therefore, that'll be equal to cosine square of alpha. I'm going to replace, that gives me 2. Cosine square of alpha is the same as 1 minus sine square of alpha. Now, if you want, we can start working with this part here. But I noticed that my cosine's on the denominator, so I can just think about 2 times 1 is 2. Do you agree? So therefore, 1 over cosine square of alpha will be equal to secant square of alpha. And therefore, I can bring this down. Or if you have chosen, you could have worked, once you get to this point, if you get stuck, you can start working with the right-hand side and decide, no, secant square of alpha is 2 times, we know that secant is 1 over cosine, so therefore that'll be 1 over cosine square of alpha. Then you multiply, 2 times 1 is 2, 1 times cosine is 2 over cosine square of alpha. And therefore those two expressions were the same. So you can work with the left or the right, but you must arrive at the same expression on both sides. Remember, you cannot add on both sides, you cannot multiply on both sides. This is not an equation. We need to simplify one side or the other and arrive at the same thing. Example number 3. Go and write it down, and then we'll start once you are ready. So for this example, we have double parentheses and there's a multiplication in between. So many times we start a process, it might not get us anywhere. We are very tempted to multiply this out, correct? It's kind of asking to be multiplied. But notice that we have secant square of x minus 1. And that will take us to our Pythagorean identities. So therefore, if I move the 1 to the right, it becomes a negative. So that expression will be equal to tangent square of x. So this will be tangent square of x multiply, and I'll place in parentheses, sine square of x minus 1 will be equal to, if I move, my sign has to be positive. So if I move my 1 to the left, we can say negative. Therefore, my cosine to the right, we can say negative. Let's do that on the left-hand side. So we have sine square of x plus cosine square of x. We know that equals to 1, correct? I need my sign to be positive. So I'll keep that one positive. I'm going to move my 1 to the left, so that way we have my negative 1, and my cosine to the right. So therefore, the sine square of x minus 1 is equal to negative cosine square of x. So therefore, this expression will be equal to negative cosine square of x. So now what should I do? Correct. Now I'm going to change everything to sine and cosine and see if anything cancels so I can have sine square of x. Well, I know that tangent is y over x, which is sine over cosine. So therefore, this is going to be sine square of x over cosine square of x multiply, and I can place in parentheses or just multiplication. Well, I have this as a fraction, 1, negative cosine square of x. My cosine square of x will cancel out. And negative times sine square of x will be negative sine square of x. And therefore, we arrived where we needed to be. But you have to keep in mind where you need to get to in order to be able to do this properly. Sometimes you start to multiply it out and you say, well, hold on, that's not getting me where I need to be. So then you can go back and try another strategy. The more you do this, the easier it gets, the more patterns you start to see. So hopefully after doing the homework for 10.1a, this should be a much easier process. Example number 4. Verify the following identities. Then copy them down, pause it, and we'll start once you are ready. So let's start with letter A. Do you want to start with the left or the right? Should we start with the left? So I'm going to change everything to sine and cosine. I know that tangent is cosine over sine. But you can start with the right if you choose to. Plus cotangent is sine of x over cosine of x. And at this point, some of you are tempted to cancel your sign, but there's a plus in between, so you can't. But we learned that we should be adding both fractions, correct? So once you have a fraction, you should add the fractions together. In order to add two fractions, you must have the same denominator. So therefore, I'm going to take this cosine and multiply on the left, numerator and denominator. I'm going to take the sine and multiply on the right, the numerator and the denominator, to have the same equivalent expressions. So you're going to say, well, what does that achieve? Once you multiply, you start to see it. They're going to have the same denominator, so I can combine them into one fraction. And now we're going to have cosine square of x plus sine square of x. And we know that cosine square of x times sine square of x is equal to 1. And now, remember, that this is where we need to get to. Secant square of x, cosecant square of x. Well, 1 over cosine and 1 over sine, that should get us there, right? So one of the things I do, I say, 1 times 1 is just 1. So therefore, I know that this expression is equal to secant, and that expression is equal to cosecant. So therefore, we are there. This gives me secant of x. This gives me cosecant of x. And now both expressions are equal to each other. And we prove that. We verify that the identities above are true. Well, this was true. Now let's continue with the second one. Go and pause it. See if you can do letter B by yourselves. See what strategies you can use to verify the identity. Go and pause it. Excellent. So let's see. Did you start with the left or the right? Well, let's start with the right, right? Cotangent, we're going to change to sine and cosine. And we're going to see if it drives us anywhere. If not, we'll start on the left. Cotangent, I know that is cosine of x, of y, over sine of y, times. This is on the numerator. So that gives us cosine square of y over sine of y. And you might think, well, okay, what else can I do? So if you get stuck, then I want to switch over to the left hand side. I said, well, I have two fractions. The first thing I want to do, I want to change it to an addition and change that to the opposite. That is the first thing that you should do every time you have a minus. If you have two terms here, then you make them both the opposite, because the negative belongs to both of them. In this case, I just have one. I'm going to change my cosecant of y to sine and cosine. In this case, I can change to sine Or I know that 1 over cosecant is sine, correct? We have that expression. So we know that will be equal to sine, so therefore it will be plus negative sine, or we can just say minus sine. So 1 over the sine of y plus negative sine of y. I'm going to place over 1, and I'm going to add my fractions. In order to add them, I need to have the same denominator. So therefore, I'm going to need a sine of y on the left, cosine on the right. And now I'll have the same denominator. I'm going to end up with 1 over the sine of y plus negative sine of y squared over 1 times sine will be sine of y. And now we have the same denominator. You probably might have skipped this step, correct? And gone directly into the same denominator, 1 minus sine square of y. And we know that 1 minus sine square of y, which we used on the last example, correct? If I take my sine and move it to the right, because it's a negative, equal to cosine square of y. So therefore, it will be cosine square of y over the sine of y, and we can just bring this down. We are done. Questions? So therefore, we confirm both identities are true. Example number 5. So go and copy it down, pause and see if you can work it out by yourselves. What strategies should I use to be able to confirm or verify this identity? Go and pause it. So that's it. First, I noticed that there's a plus in between. So I'll switch everything to sine and cosine. I'm going to add both fractions and see where that takes me. Secant of y, I know that it's going to be the same as 1 over the cosine of y. Tangent is sine over cosine. Oh, and we have the same denominator, which is great. And we have 1 plus the sine of y. Remember where we need to get to. Well, we can separate our fractions, but we're going to end up with what we started with. Any clues? So one of the clues that you should be able to see is that on the denominator, we have 1 minus sine of y. So we are going to multiply by the conjugate. So we're going to multiply by 1 plus the sine of y. Use the dye red. And what am I going to do that? Do you have any, where is that going to take us? Correct. That's going to be the difference of two squares on the denominator. Correct? And that is going to allow us to simplify using our Pythagorean identity once again. So therefore, for 1 plus, not minus, we want it to be difference of two squares. So therefore, my numerator will be cosine of y times 1 is cosine of y. Cosine of y times sine of y will be plus cosine of y sine of y over 1 minus sine square of y. The denominator will be equal to, move the sign to the right, it will give us cosine square of y. So therefore, it will be cosine of y plus cosine of y sine of y over cosine square of y. So I replace those two values. And notice that we're almost there. Now, there's going to be times that I don't multiply my numerator because notice that those two expressions are the same. So if I just simplify that, if I now multiply this out, then I could have just canceled one of the cosines. But if you don't see it, then you have to make sure that you see that you can factor out a cosine. And that gives you 1 cosine times sine of y. So the more you do this, the more patterns you start to see. And sometimes you say, I'm not going to multiply my numerator because I see it 1 plus sine of y. So that part will take me there. One of the cosines cancel. Cosine of y cancels with one of them. So therefore, the only thing that we're going to have on the right-hand side is 1 plus the sine of y over only 1 cosine of y. And that's what we have here. But you do have to be careful that you must work in a vertical manner. Your equal sign should be 1 equal to 1 on top of the other on top of the other. You cannot work sideways. Everything has to be in a vertical manner, just like we've been doing on the last 5 examples. And therefore, we verified that this identity is true. Example number 6. Give it a try. See what you get. And then we can compare our answers. Your process might be different than my process. Go and pause it. You got it? So let's see. We see cosine square of cotangent in 1. We know the cotangent in 1 is here. So I can replace it with cosecant. Correct? I also can replace cotangent minus 1. No, that cannot happen. So therefore, I'm going to replace my denominator with cosecant square of x. So therefore, I'm going to end up with cotangent square of x minus 1 over cosecant square of x. Well, how's that going to help us? We can separate the fractions because we can replace this part with a plus 1 and minus 1. But I notice that I need to end up with sine square. I want to separate my fraction. I want to separate my cotangent square of x over cosecant square of x minus or plus negative 1 over cosecant square of x. Correct? If I go backwards, they have the same denominator, then I can just subtract. I know that this will give me a negative sine square of x, because that is 1 over cosecant square of x. And I can change this to sine and cosine. Cotangent of x, what did I write then? Cosine of t. There's an extra s in there. Cotangent is equal to cosine square of x over sine square of x over 1 over cosecant square of x. From last time. What's wrong with that? What did I do wrong? Yes. So I want to change cosecant to sine. I want to replace cosecant square of x with sine. So we're going to change everything to sine and cosine. And now I can take the reciprocal on both sides if I need to. I can change the reciprocal to multiplication, take the reciprocal of the denominator, or I can multiply the numerator by sine square of x. Make sure you place it on the numerator. My denominator, my sine square of x, place it on the numerator of your denominator. Therefore, those two expressions cancels, those two expressions cancels, and end up with cosine square of x minus sine square of x. And you might think, okay, yes, how does that help us? Interesting question. Can you guys see the answer? So what we're going to do, because I have one negative sine square of x, and I need two of them, right? I'm going to replace cosine square of x. I'm going to move my sine square of x to the right because it's a negative. So cosine square of u of x equal to 1 minus sine square of x minus sine square of x will give us negative 2 sine square of x. So give me 1 minus 2 sine square of x equals, and we are done. Right? It was just one step away, but sometimes it is challenging to be able to see what should be the next step. It requires lots of practice to be able to see some of the patterns. And the last example for today, verify the following identities. Let's start with A. Go and copy it down, pause if you need more time, and we'll continue once you are ready. So this is a skill that you'll need for calculus. I need to simplify the left or the right. Notice that on the left, we have two expressions that have tangent. So therefore, I'm going to factor out the tangent. If I factor out the tangent, what's left? Tangent of x times secant square of x. Tangent of x times negative 1. Now we have a trigonometric function square and a 1. That should drive us to either one of those three. If I move the 1 to the right, it becomes a negative, so that'll be equal to tangent. So therefore, this expression will be equal to tangent square of x. And we have another tangent, and they'll multiply, so therefore we have tangent cube of x is equal to tangent cube of x. We proved that the identity was true. Letter B. What should I do? Well, let's see. I have a cosine cube and sine to the 4th power. We have sine to the 4th power minus sine to the 6th power. So therefore, notice that we have, there should be some similarities in here, right? I have a cosine in here. Now a cosine in here. So therefore, I need 4 sines. So I'll take out 4 sines from here. Or sine to the 4th power. So sometimes we need to start with the left, sometimes we start with the right. So I want to take out 4 of the sines. And what's left behind? So let's see. I'm going to write my cosine first. Might make it easier to see. I'll write down my cosine of x times, because they're multiplying. I want to factor out 4 of the sines. So sine to the 4th power of x. And what's left behind? Sine to the 4th power of x times 1. And sine to the 4th power of x times sine square of x. And we know that this expression is equal to, so now you can see it, right? Yeah, sometimes it can be a little more tricky to see the patterns and what should be the next step. But now I know that if I move my sign to the right, it becomes a negative. So therefore, that expression is equal to cosine square of x. So we have cosine of x multiplied by sine to the 4th power of x, and that expression is equal to cosine square of x. Therefore, I have my 3 cosines that I need. So cosine to the 3rd power of x times the sine to the 4th power of x. And therefore, we proved that those two expressions were equivalent. We proved the identity. You think you got this? Try the next example. Let us see. Go and pause it and see what you get. Well, let's see. I noticed that they both on the left-hand side have a cosine. At this point, you should have tried it out, right? If not, go and pause it. Notice that they both have cosine, so see if we can factor out something. Right, so they both have cosine. So I can factor cosine. Remember that we always factor out the smallest value. So we have 5 halves and 1 half. I'm going to factor out 1 half. And remember that cosine of 1 half is equal to the square root. Correct? So that's taking us somewhere. Cosine of 1 half times x of x multiplied by what will give me cosine of 5 halves of x. Correct. Cosine of 4 halves, because whenever we multiply exponents, we actually add them, so it gives me 5 halves. Whenever we multiply two expressions, we add the exponents. And cosine to the power 1 half of x times -1 will give me what I need. Well, I know that this is going to be the square root, and I'll rewrite it as the square root of cosine of x. Remember, this is the root, and that is the exponent. We don't need to place a root of 2. We don't need to place an exponent of 1. And this is cosine square of x minus 1. Move the 1 to the left, and the sign to the right becomes a negative. Negative sine square of x. And this gives me the square root of cosine of x. We just need to be able to rewrite it in order to be able to, it needs to be in the same order. So we do need to take an extra step. So these are skills that are essential for you guys to be able to do well in calculus. This is a skill that can be difficult for many of you. But in calculus, they're going to expect you to do simple algebraic simplifications, such as this. So this is the lesson for today. Have a great day, and I'll see you next time.